Hey guys, this lesson is on calculating pH and the concentration of H3O positive, which just means like the concentration of H positive or acid. So you guys are going to need to look at page 11 of your data book. Hopefully this video sees you guys doing well. Good job on that last assignment. Most of you guys finished it and did a good job on it. So hopefully you're getting this so far. So basically what we're going to be doing today is we're going to be calculating pH. And H3O positive concentration, which is just the same thing as H positive concentration, right? So basically you guys should know, like, if you're strong acid, because I told you this, you make more of these, right? Because you're able to disassociate, and the stronger the acid, the more of this you make, right? And so this we use, right, this, how many of this to calculate that concentration, right? So you guys should remember that the pH scale is between 1 to 14, and basically 1 is, and then 7 is sort of like neutral. So from 1 to 7 and 7, 14. So 7 is neutral, and 1 is the strongest acid, and 14 is the strongest base. Right? And so, like, the stronger the acid, the more H positive you're gonna have. Remember, neutral will be ionic or molecular. Those guys are neutral. They have a pH of 7. But anything between 1 and 7 is an acid, and anything between 7 and 14, is a base. Okay? So just so that you guys know, right, pH stands for power of hydronium. Okay, so pH stands for power of hydronium, and hydronium is that H positive ion. So basically, if you have a pH of 1, right, that means you're 10 to the negative 1 in terms of the concentration of H positive, right? If you have a pH of 2, that means this is 10 to the negative 2. pH 3 is 10 to the negative 3. pH 4 is 10 to the negative 4. So you can see, right, that if you have 10 to the negative 1, that means your concentration of H positive is 0.1. If you're 10 to the negative 2, your concentration of H positive is 0.01. If you're 10 to the negative 3, the concentration is 0.001. If you're 10 to the negative 4, the concentration of hydronium is 0.001, right? So pH of 1, you can see, has the highest concentration of hydronium ions at 0.1, right? Because 0.1 is bigger than like 0.4, right? So this is 10 to the negative 4. This is 10 to the negative 1, right? This one over here at 0.1 is definitely more concentrated than if you have pH of 4, which is 0.0001, right? So you can see that the higher the pH, the more concentrated H positive you have, until you go all the way to pH 14, and guess what? Your concentration of hydrogen is 10 to the negative 14, which is 0.000001, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way, like, look, sorry. That is the concentration of hydrogen. You barely have any hydrogen, like minuscule, very, very small amounts of hydrogen when you get to pH 14. And that's what makes this so basic, right? Because the power of hydrogen is really low here. And you guys can see that, like, this is 10 times smaller, right? So 10 to the negative 2 is 10 times smaller than 10 to the negative 1. So they ask you to do calculations, right? So, like, what if they said, what is the difference, right, in pH between 1 and 3? Okay, between 1 and 3. Well, you can see that between 1 and 2, there's a 10 times difference, right? 10 to the negative 1 is 10 times more than 10 to the negative 2, right? And between 10 to the negative 2 and 10 to the negative 3, that's also 10 times, right? So 10 to the negative 2 is 10 times stronger than 10 to the negative 3, right? You can see that 0.01 is 10 times more than 0.01, and that 0.1 is 10 times more than 0.01, right? So we're basically increasing, right? As we increase pH from 2 to 1, right? It's an increase of 10 times more. If we increase the pH from 3 to 2, that's 10 times more, right? So if you're looking at a question like this, what's the difference in pH between 1 and 3, right? Well, it's going to be 10 times, right? Between 1 and 2 is 10 times. Between 2 and 3 is 10 times. So what's 10 times 10? 100 times difference between pH 1 and 3, right? And if they ask you, okay, watch. So you can see here in this question, solution A, so I'm just going to write it down. So it says solution A's pH is equal to 6, this is pH 8, and this is pH 11. So this is solution A, B, and C. So solution A has how many more hydronium ions than solution B? Well, if this is pH 6 and this is pH 8, that means, right, between 6 and 7 there's a 10 times difference, and between 7 and 8 it's 10 times different. So the difference between A and B is 100 times, right? So solution A has 100 times more hydronium than solution B. And then between solution B and C, okay, so this is a pH of 11 and this has a pH of 8. Well, that's going to be 10 times 10 times 10. So the difference is going to be 1,000 times, right? So solution B has 1,000 times more hydronium than solution C. pH 8, pH 11. And that's how you calculate that, if they, right? So hopefully that made sense. And what we're going to do now is, this is really easy on page 22, where you guys have to calculate pH. So there's two equations. You got to look at page 11 of your data book. You got to look at the bottom of it. Okay, so right here, the bottom of page 11 of your data book. It's kind of blurry, but there's the formulas over here. And see, these are the formulas they give you. pH is equal to negative log, and it gives you H3O positive, and then it says H3O positive is equal to 10 to the negative pH. So you guys are going to need a calculator, okay? It doesn't have to be this kind of calculator, a TI-83 calculator. It can be a regular calculator that has the log notation on it. So here we go. If it gives you, okay, if it says, hey, pH is 7, what is hydronium concentration? And hydronium is just like the H positive. That's all it means, right? So if you have a pH of 7, what's the hydronium concentration? Well, which equation are you using? Are you using this one or this one? Well, it's asking you for hydronium concentration, so you're going to use this one. And in order to calculate that, you got to go H3O positive is equal to 10 to the negative 7. So 7 is the pH, and that's the number you put in there. Okay? And so when you do that, right, here's the calculator, you clear it, okay, you go 10 to the power of negative 7 is equal to, the hydronium concentration is equal to 10 to the negative 7, right, or 0.1234567. That's the hydronium concentration, which is actually a 1 here. Okay, so you're going to see that show up on your calculator. Okay, we're gonna do another one. Okay, so what if they say the pH is equal to 3.4? What is the hydronium concentration? Okay, again, you guys go H3O positive is equal to 10 to the negative pH. And so what's pH? 3.4. So you guys go 10 to the negative 3.4. Okay, so you go 10 to the negative 3.4. And guess what? That's your hydronium concentration. The hydronium concentration is 3.98 times 10 to the negative 4. And that's all you do. Okay? So that's to calculate hydronium. But what if they ask you to calculate pH? So basically they tell you that the hydronium concentration, let's say, is 6.7 times 10 to the negative 7. Okay? And the concentration is measured in moles per liter. What is pH? Okay, well, you got to use this formula, right? The pH formula. That's the one you're going to use. So you're going to go pH is equal to negative log, and you're going to put that number in, 6.7 times 10 to the negative 7. Okay, so I put that in. Okay, so negative log 6.7 times 10 to the negative 7. And what do I get? The answer is 6.17. Hey, that's my pH, right? So I just calculated pH, right? They're giving me the concentration of the hydronium. I calculated pH, right? So that's how easy this is. And there's like a data table right here where you guys can try. So it says here, hey, it gives you H3O positive. It asks you to calculate pH. Okay, so you guys can do this table and you can try it, and it's really easy, right? So like we can even do this together if you still are kind of confused. So they give you that H3O positive is 1.0 times 10 to the negative 6. The units is moles per liter. What is pH? Okay, well, pH is equal to, the formula is on page 11, negative log 1.0 times 10 to the negative 6. They give you that. And when you calculate it, you get a pH of 6. And then the following question, let's say pH is 3.5. Okay, if they give you that pH is 3.5, then what is H3O positive? So then you go, okay, well, H3O positive is equal to 10 to the negative pH. And that's equal to 10 to the negative 3.5. So then you just put that into your calculator, right? 10 to the negative 3.5. And there you go, you get your answer. The H3O positive is 3.16 times 10 to the negative 4. And the unit for concentration is moles per liter. Okay? And that's how you do it. So what I want you guys to do, okay, for homework, is try these questions on page 23 and 24. Okay? Try the questions in your book, page 23 and 24, and you guys are going to submit that for homework, okay? There's going to be a couple more pages you're going to do for homework, but that's the homework for this lesson. Okay, take care. Bye.